This is a example of a complex Fourier series, which was requested by Last Hero, I think that's his name, or Last the Hero, I don't know. Right, now I'll go along with it, but as with complex Fourier series, and any Fourier series, they're very long, so there's a lot of pasted in, which you'll find out in a minute. Right, now first off, the definition, if you didn't get this from the last video, then with our equation f of x is equal to c0 plus the sum from n is minus infinity to infinity, this is like the boundary of it, of cn times e to the I nx. Now e to the I nx is the same as cosine nx plus I sine nx, yeah? And cn in this case, and c0, just replace the n's with zeros, is 1 over 2 pi times the integral from minus pi to pi of f of x, our function, times e to the minus I nx dx. Now don't forget that minus, because I did in this example, and this is the second time I've recorded this. So here we go. Right, now our example. Our function is t squared, and it's on the minus pi to pi. Now, first thing we should normally do is get our c0, which is, remember, 1 over 2 pi times integral from minus pi to pi, because that is our boundary, of t squared times e to the 0, which is 1, dt, which integrate this, and we get pi squared over 3. Our cn, now this is the tricky part, this is the part that takes forever. It really does. That's why these questions are worth a lot of marks in exams. Sometimes up to like 15, 20 marks. Cn is 1 over 2 pi times integral from minus pi to pi of t squared e to the minus int dt. Now, what you're doing with this is, with our minus int, we're just putting, instead of nx, we put minus nx. Nx. So it doesn't make a difference with the cosine because it's symmetric about the y-axis. Yes. But for this sine one, we take the minus out and put it there. Now I forgot to do this the first time around, so please be careful with it. And as you can tell, this isn't going to be very nice, but you can see with a I don't know if you can read this, but if you can't, then I'll upload it onto Rapid Share, where you can download it free, the working out, or you can put it into a program. I put this into Maple to work it out. So it's the function we've got here, and it goes down, solving them. I've had to put in like minuses because I made it wrong the first time, but it works out the same answer, thankfully. So there might be a plus or minus wrong in a few places, but I'll put the right working out on. So use integration by parts, substitution, that kind of stuff. We're slowly getting along. Yeah, you might want to pause the video halfway through this, just to have a look at what's going on. Yeah, and then we're going down this way. But it is very, very long, and I can't really be bothered to go through it all, as you can probably understand, because it's still going on. These pluses are a bit bold, just because I've just inserted them. That shouldn't, there's a little tiny line there, just ignore that. That's not really a minus. Yeah, so we're just working with the first part here. The second part is left the same for the moment until we get over here where stuff's being changed, slowly progressing. And this, we're at the final page, thankfully. And as we work along here, finally you will end up with this, which is 2 times pi squared sine n pi over n minus 2 times minus 2 cosine n pi times pi over n plus 2 sine n pi over n squared over n. Now, one thing you can know, for sine pi, which we have here and here, sine pi is always 0. So if you multiply pi by anything, you'll always get 0. So these can actually just cancel out. So we've got the 0 there, we'll cancel that out, and we can cancel this out as well. So what we're left with is minus 2 times minus 2 cosine this over n. Now, first off, the n squared, the n's will turn into n squared, which is pretty straightforward. And this cosine n pi can be simplified because what it is, if you try it on your calculator, you'll have cosine 0, which is 1, cosine pi, which is minus 1, and so on. So we can see it's alternating between minus 1 and 1. So we can change this to minus 1 to the n. So that's quite standard. You should learn that. It's quite useful. And then we've got our minus 2 in front of it. We've got the minus 2 over here. We can't forget our pi. And it simplifies to this. 4 times minus 1 to the n times pi over n squared. Now, going back, this is what I've left out. If I go back to here, I've left out this 1 over 2 pi just because we're solving this. Now you can put it in if you like and solve it that way, but I've just left it to the end. And if we multiply it, then the pi will cancel, the 2 will cancel, and have 2 minus 1 to the n over n squared. Now, as we said back in our beginning, the definition, we have the c naught, which we found there, pi squared over 3. We have our cn, which we've solved here. So we put them in. We have our t squared can be expressed as pi squared over 3 plus the sum of 2, this is from minus infinity to infinity, but n can't be 0, which is fair enough, yeah. 2 times minus 1 to the n over n squared times e to the I n t. And that is your solution. I hope it's readable, but it is very long.